Right, welcome to our online viewers and welcome to everyone here at the Health Pavilion at COP27. We are going to be talking about the role that the ocean plays in our health, and we have a jam-packed session both virtually as well as here in person. So it is with great pleasure that I would like to invite Ms. Maxine Burkett, who is the US Deputy Secretary for the Oceans, who is going to provide us with some opening remarks that will set the scene for what we're going to be discussing today. This event is also a joint event between Land Body Ecologies and the One Ocean Hub.
Thank you so much. Thank you for the invitation to be with you today. It's an exciting lineup. I certainly don't want to get in the way of the powerhouse speakers that you have on the stage today. I do want to bring greetings from the Bureau of Oceans, International Environmental and Scientific Affairs at the U.S. Department of State and highlight 3 areas of work where my team is heavily invested in the nexus between health, the ocean, and climate change. The first is coastal community resilience. Whether we're talking about cholera or harmful algal blooms, life-threatening storms, or even underappreciated issues such as mosquito-borne diseases in island states, there's no question that coastal communities are at the front line of climate impacts. We are working, especially through the President's Prepare initiative, on climate adaptation to bolster community resilience in the face of these threats. For example, we're working with partners in several Pacific Island countries to create an islander-led, climate-based early warning system for dengue fever. The second area of work that I'd like to highlight is blue foods. The ocean delivers enormous nutritional value to communities around the world, not just on the coast, but to all of us. And these benefits are delivered not only in the form of caloric content. Globally, fish provide as much animal protein to people as poultry, and more than comes from other forms of meat, but also in the form of healthy diets. My team works to negotiate and maintain mechanisms that make management of international fisheries robust, sustainable, and science-based so that these key life and health supporting resources remain viable. The third is sea level rise and the impact it has on our infrastructure. Sea level rise is one of those issues that has profound impacts on so many sectors that health can sometimes get lost in the conversation. But whether you're talking about water and sanitation systems or community health centers or even transit routes that bring patients and staff to the door of the hospital, all of this care infrastructure is at risk amid rising seas. So our Prepare initiative also includes several lines of effort focused on healthcare delivery as well as community-based public health. Moreover, we have a domestic program, Healthcare Climate Pledge, that includes commitments from U.S. healthcare providers to not only reduce greenhouse gas emissions, but also to create resilience plans to support continuous operations. These are the sorts of plans that we need from health sectors all around the world moving forward. So with that, I'll cede the floor to the distinguished speakers, and I very much look forward to the discussion here in Sharm and well beyond. Thank you so much.
Thank you. That was really an excellent introduction, and also the complexity when we talk about the ocean and about the health and all the different role players and what we need to bring to the table, and also a stark reminder of who are the vulnerable people who are being impacted by climate change. So without further ado, I think it would be important for us to start our schedule and listen to a whole range and host of different speakers who are going to be joining us today. We're going to start with playing a short video on some of the research and biodiscovery research that is undertaken in South Africa. We have a bit of a sound issue. Okay, we still have no sound. How important that biodiversity is, because the more biodiversity you have, the better your chances are of discovering something new. South Africa, from a marine point of view, is incredibly fortunate. We have a very long coastline of over 3,500 kilometers. And within that coastline, we have a number of bioregions. So these are environments that specifically have very defined habitat. So Algoa Bay and the regions around it, which are in the Agulhas bioregion, is particularly rich in marine biodiversity, and especially so with the marine organisms on the ocean floor. The sponges and sea squirts and corals and soft corals, etc. And specifically the bacteria that live with them, so they're microbes. And it's really important that we acknowledge how important that biodiversity is, because the more biodiversity you have, the better your chances are of discovering something new. So to explain the sea to laboratory process, we go out into the field and then we use equipment known as remote operating vehicles, or ROVs. And the ROV has really good camera equipment and video equipment, and we can then use that to identify sponges or sea squirts or organisms that are down there that are potentially of interest for us for research purposes. And then we use a robotic arm on the ROV so that we can specifically collect the specimens we're interested in a non-destructive way without damaging the reef habitats. And we also make sure that we're not taking the only specimen that is there. And then we also take samples for a DNA analysis. And the DNA that we isolate is used to potentially identify the genes that the bacterium uses to make that chemistry. We call it gene mining. We will then use genetic engineering to see whether we can persuade a bacterium that grows in the laboratory, such as Escherichia coli, our gut bacterium, and persuade this bacterium to produce the compounds we're interested in the lab. And the compounds we have are also screened in our collaborating labs for anti-cancer activity and for potential inhibitory activity against malaria and other parasites. So the compounds that we get from the sea, those don't necessarily end up in the pharmacy, but what they do is they give us ideas about what kind of compound can be used to target these diseases, so that we can go into the lab and develop these ideas into fully fledged pharmaceutical compounds that can be tested and put into clinical trials.
Hi, I'm Jazz, and I'm a PhD student researching natural product development at the University of Plymouth. My main focus is on deep sea sponges and their diverse microbial communities, with the view to discover novel bacterial species with bioactive molecules to solve medical challenges such as antimicrobial resistance. We work alongside the marine biologists. Essentially, they collect and preserve the specimen. We then process the specimen in a way that enables us to access the microbial communities within. We then select bacteria of interest based upon morphology, size, texture, and colour of the colonies that grow on the agar plates. Bacteria can take many forms. few years, we have seen a rise in bacterial infections that are becoming increasingly difficult to treat. This is due to the bacteria being able to mutate and survive against the antibiotic that would have originally killed them. This bacteria can then pass on the mutation to other bacteria, over time causing the antibiotic to become less effective. Therefore, our role is to find alternative antibiotics to treat these bacterial infections.
Great, thank you. I hope you managed to hear most of that. The sound did go in and out a little bit, but hopefully it was available to you. And it is my pleasure to invite our first online speaker, who's going to talk a bit about One Health in practice, opportunities and challenges. I don't know if she's online at the moment or if we're going to be able to play a video, but I would like to invite Dr. Claire Lajaunie, who is from INSERM, and she will be giving a virtual presentation.
Hello everyone, can you see the screen? Is it working?
Hello Claire, yes, we can see the screen, welcome.
Oh, okay, hello everyone, thank you very much. And I will briefly present the interest of the One Health approach in relation to the ocean and climate change. And here, the One Health approach has been used for years in relation to infectious diseases, but gained interest during the pandemic with the creation at the international level of the One Health high-level expert panel, associating the FAO, the International Animal Health Organization, the WHO, and UNEP, to enhance coordination at the international and national level to provide policy-relevant scientific assessment on the emergence of health crises. And the One Health approach is an integrated approach that aims to optimize the health of people, animals, and ecosystems, and to consider their close links and interdependence. So the point is to mobilize multiple sectors, disciplines, communities at different levels of decision making, and to address different issues and mainly take action on climate change and contribute to sustainable development. I had the pleasure to organize a session on One Health and the ocean during the Science Summit last September, and we discussed different topics in relation to health, such as ocean transportation, the need for data in relation to One Health, microplastics, or the Pacific Ocean and the perception of policies towards One Health, or the link with the SDGs, and the main issues beyond the different disciplines that the main concerns were the issues related to the lack of interlinkages between norms and policies from different sectors, the lack of global standards when it comes to microplastic collection, or lack of consistency regarding the various norms, the need for the best available ocean science observation data and services, and Karina will speak about it, the interest for ocean policies focusing on intersectorality to facilitate the implementation of the One Health approach, and the COVID-19 may be the opportunity to shift from the implicit use of the One Health approach to its explicit use. So there is need to go from science to political action with a joint plan of action published by OLEP and the theory of change. And we can see there are outcomes in the short term, and one of them is to improve One Health governance at all levels, and it's our work as scientists to be involved into that movement. So thank you for your attention.
Thank you so much, Claire. We will move on to our next panelist, which is Pierre Mazega, who will also be providing either an online or a virtual, if he's able to join us online.
I'm presenting on his behalf.
Oh, thank you, Claire.
So I'm staying here.
All right, Claire.
I will present our work on One Health and the ocean and policy path to the SDGs. So quickly, we did the previous work on the existing scientific research in relation to One Health with the extraction from the Web of Science of more than 5,000 publications associating 174 disciplines in relation to One Health, and we came with a glossary on One Health with more than 6,000 expressions. And the point is to find the conceptual path connecting One Health, ocean, and SDGs. So we studied 21 policies, international policies in relation to the ocean. From those policies, and I'm sorry I cannot present them, so very briefly, the agenda for sustainable development of the UN General Assembly, or a document from the World Bank on the blue economy, for example. Among those 5 policies mentioning the One Health, the point was to retrieve the path from health to the SDGs, to connect the different concepts on the basis of their occurrence in the text, to extract the path and to see the direct link explicitly given by the text, or the latent indirect path, the latent connection on going from One Health to the SDGs. So I will give an example. Here, for example, the document of the UNESCO, The Science We Need for the Ocean We Want, shows explicitly ocean health in relation to knowledge and to the SDG 14 or to the SDGs in general, while another document from Europe is showing the link between environmental health to climate change and the different SDGs you can see here. But the interest is also the latent path to the SDGs, where ocean health is going through different ways to developing countries, least developed countries, to different SDGs. And here, the main evidences we found is that only, as I said, 5 texts in the corpus mention ocean health. Ocean health is associated with public, human, environmental health, but never associated with animal or wildlife health, which can be an issue. The link to the SDGs is generally made indirectly without any intention, and direct links are only indicated with SDG 14 or with the SDGs as well. And in conclusion, I can say that little attention is given to the potential of the interdependencies between One Health, ocean, and the SDGs, and their relation is often purely omitted. Well, the next step is to better understand those links and to strengthen the dialogue between science and policies, and between the policies and the different institutions, to structure a coherent set of actions. Thank you for your attention.
Thank you so much, Claire. Packed quite a lot of information into the short little period that you had available to you, as we have so many speakers. You're going to now have interventions from 3 speakers. We're looking at the different pathways. We're looking at equity, biodiversity conservation, and biodiscovery. Our first speaker will be also, and all of them are virtual, will be Professor Rachel Weinberg, followed by Dr. Jessica Lavelle, and then followed by Professor Matthew Upton, who are working together along these different aspects and components. So I'm going to hand over to Rachel, which I'm hoping is online or is also a virtual presentation that's been presented.
Thanks, Berlina. I'm here. Can you see my presentation?
Not yet. Just hold on. I'm sorry, I can't see the tech stand. Okay, we can see you, Rachel. Welcome.
Okay, thank you very much. So thanks very much for those inputs. My focus today shifts a bit, although it is related, and it's looking in particular at the ocean genome and its importance, linking to the video we saw earlier. So its importance in understanding the ecological, the economic, and the societal benefits that marine genetic diversity provides, especially in the context of our changing world. Its importance in supporting efforts towards climate change, adaptation, and mitigation, and in strengthening opportunities for the improved conservation of the ocean, the ocean genome, and the more sustainable and equitable use of marine genetic resources. And I've got a few short points to make. And the first is that the ocean genome, and here I mean the genetic material that's present in all marine biodiversity, including both the physical genes and the information that they encode, so-called digital sequence information, is the foundation upon which all marine ecosystems and their functionality rest. It also underpins sectors such as fisheries and aquaculture, which collectively form a pillar of global food and health security and human well-being, and its use in research and development, which leads to new medicines, cosmetics, foods, and other products that are important for our well-being. Yet we know that the ocean is severely threatened by overpopulation, by habitat loss and degradation, by mining and associated exploration, pollution, impacts from a changing climate, invasive species, and other pressures, as well as the cumulative effects of all of those. But there are some important steps that we can take to ensure the conservation of the marine genome. And the first and possibly the most important is to include and recognize the value of marine genetic diversity in marine spatial planning, in sector-specific management plans, in strategic environmental assessments, in climate mitigation and adaptation measures, and other tools. The invisibility of marine genetic diversity, particularly when we get down to the microbial forms, means that this component has been largely neglected to date. And the second is to use opportunities that already exist within marine biodiscovery research and commercialization. These are obvious, but they often are not applied in practice. So-called access and benefit sharing measures could, for example, require those applying for bioprospecting permits to provide information about how the activity will contribute to the conservation and sustainable use of biodiversity. And this might be through, for example, enhancing the taxonomic knowledge of marine biodiversity, as well as research on the functional biology of the ocean, and ensuring that data is shared and is accessible. And it could also be through capacity development and technology transfer to support the conservation and sustainable use of biodiversity, especially for low and middle income countries and for coastal communities and indigenous peoples. Funders of biodiscovery programs could have conservation as an explicit requirement of the grant, requiring some of these measures to be included. And as an important principle and an overall approach, conservation should be embedded in all benefit-sharing agreements and mechanisms. And collectively, these actions could make a small but very important step towards ensuring the conservation and the viability of the ocean genome to continue to support not only humankind, but the more than human world on this planet. I thank you very much for listening.
Thank you so much, Rachel. And I think there are some really important points that you have mentioned in terms of the link to culture, the economies, linked to indigenous people, and also the impacts that we are facing on this. Now I'm going to hand over to Jessica, who is also joining us virtually.
Thanks very much. I'm just going to take a minute to get myself organized. If you would just give me a minute. Sorry, I'm just having some trouble sharing my screen. There we go.
We can see.
Is everyone able to see my screen?
We can see it. Thank you.
Okay, fantastic. Right. So the vision of One Health is of collaboration at local, regional, national, and global levels to achieve optimal health outcomes for people and also all other biodiversity we share our ecosystems with. This goes beyond terrestrial environments and also includes the ocean, where the future of planetary and human well-being is dependent upon a thriving ocean genome and environment. However, to protect our oceans requires in-depth knowledge of its biodiversity and also the associated ecological processes, including the impact of climate change. This also holds true for us to be able to unlock the potential benefits of marine biodiversity for biodiscovery and the development of pharmaceuticals, cosmeceuticals, nutraceuticals, and other health products. While the vastness of the ocean does indeed offer innumerable benefits and opportunities, it also presents a lot of challenges for acquiring knowledge and conducting research and innovation. Increasingly, technologies aimed at the collective characterization and quantification of biological molecules using genetic data are being applied to marine biodiscovery and biodiversity conservation. These powerful approaches offer immense potential, not only for discovering novel products for health, but also for ecosystem monitoring and modeling to inform biodiversity management and ocean climate mitigation and adaptation. However, undertaking such research requires extensive sampling of the ocean genome, necessitating access to deep-sea research vessels, specialized underwater technology, and analysis capabilities, all of which come at high cost. Yet there exists a seascape of inequity in ocean science, with uneven participation in research and innovation between high-income and lower and middle-income states. Rich in biodiversity, but with limited research capacity, finance, resources, and intellectual property rights, lower middle-income states are vital custodians of the ocean genome, and their equitable inclusion in ocean science is paramount to enabling One Health. The governance of the ocean therefore requires an approach that centers both the ecological well-being of biodiversity, ocean biodiversity and ecosystems, and also enables transformative capacity building and technology transfer. The Paris Agreement, Convention on Biological Diversity, its 2014 Nagoya Protocol, and also the Convention on the Law of the Sea all offer opportunities to facilitate the co-development of capacity building and technology transfer initiatives based on the self-identified priorities of low and middle income states. By working collaboratively through these agreements, the inclusive, equitable, and effective participation of all countries in ocean science will make sure that we have a healthy ocean for a healthy society. Thank you.
Thank you so much for that, Jessica, and it came through nice and loud and clear. And I'll hand over now to Matt Upton, who is next, joining us and looking at antibiotics, antibiotic resistance.
Hello, can you hear me? Can you see my slides?
We can see some slides that says antibiotic and antibiotic resistance on it, Matt.
Okay, great.
Perfect.
Thank you. Great to be here today talking to you. And I don't know if some of you saw the previous session in the Health Pavilion on antibiotic use and AMR. Great background really in a way, but I think it's important for me to state that antibiotics are actually one of the most important medical interventions in the last 100 years. The WHO suggests that their introduction has saved 200 million lives, and they've added 20 years to the average human lifespan. And because we use antibiotics not just to treat infections but to prevent infections, they essentially underpin all of medical healthcare. But unfortunately, bacteria becoming resistant to the action of antibiotics, and this antimicrobial resistance, or AMR, threatens to undermine that medical health system. And our situation is exacerbated by the fact that we've not found any new classes, so these are antibiotics that work in new ways, new classes of antibiotics in the last 30 years. So to address this, we need to find antibiotics of new classes. And to do this, I'm looking at the deep sea. We had a great introduction at the beginning how we do this in the two videos that you saw. But I'll just remind you that Rosa mentioned that sponges and other marine invertebrates are an amazing source of diverse compounds with bioactive properties. There have been 30,000 biomedical bioactive compounds described from marine sources. And this includes 9 current cancer therapeutics that are in clinical use. And it includes compounds with antibacterial, antiviral, and antifungal activity. And it's these compounds that we're chasing in the work we're doing. And as you saw in the original video, because we can sustainably source these sponges, It means that we're not needing to collect large numbers of them and carry out repeat sampling. So it's a sustainable program of work that we're carrying out with the One Ocean Hub and also with the South African UK Antibiotic Drug Discovery Hub. The problem I'd like to raise is that sponges grow in what we call gardens, and these are found up to kilometres below the surface of the sea, and the gardens have been classified as vulnerable marine ecosystems because their existence is threatened by human activity like deep sea trawling and deep sea mining. And these ancient organisms have a very fragile existence under conditions of cold and immense pressure, and even subtle changes in the surrounding conditions might lead to their rapid extinction. So there's a genuine threat that climate change could lead to changes in temperature or the nature of marine debris arriving at the seafloor, and it's impacts like these that could destroy sponge gardens forever. So that we don't lose access to this potentially unparalleled source of new medicines, I'm proposing that we need to increase awareness of the richness of these environments to help secure their protection whilst maintaining efforts to sample the marine invertebrates and study their bioactive properties. Thank you.
Thank you so much, Matt. Always a pleasure to listen to you, and I hope everyone else enjoyed it from there. We hopefully will have some time for questions as we zoom through our many panelists. And now I think we're going to change pace a little bit with our co-hosts, Land Body Ecologies. And we're going to have our first virtual presentation by Jenny Lighty, who is, and I hope I pronounced that correctly, who's going to talk a little bit about if oceans aren't kept healthy, we won't survive. Can we have Jenny, please? Ah, wonderful. Okay, hopefully it's going to be a single screen. Apologies as we just try and sort out some technical issues. Right, perfect.
My home is in the Arctic, and my people is an Arctic people. Our whole existence in the Arctic, our culture, our language, and our livelihoods is rooted in winter, cold, ice, and snow. Due to climate change, the climate in the Arctic area is getting warmer. My home is in the Arctic, and my people is an Arctic people. Our whole existence in the Arctic, our culture, our language, and our livelihoods is rooted in winter, cold, ice, and snow. Due to climate change, the climate in the Arctic area is getting warmer 4 times faster than the global average, which causes melting, vanishing, disappearing, and rapidly changing Arctic world. We do not survive without winter, snow, ice, and snow, and we need all those things to live a good, healthy life. One of our keystone species in the Arctic Ocean is the Atlantic salmon. It is not coming back to our river anymore, to this Atlantic water system. There are many reasons that contribute to the salmon's decline, from warming to Arctic, fast changes in the ocean ecosystems, incompetent exploitation of the world oceans, to loss of biodiversity, as well as bad local ecological governance of the colonial states. The Atlantic salmon is an ecological and cultural keystone species in our traditional territory called Sápmi. Our well-being is connected to the well-being of the salmon and the river. I would like to read a poem by Jack Forbes, which inspired us in making this exhibition at the Pavilion. I can use my hands and still live. I can use my legs and still live. I can use my eyes and still live. I can use my hair, eyebrows, nose, arms, and many other things, and I still live. But if I lose the air, I die. If I lose the sun, I die. If I lose the water, I die. If I lose the plants and animals, I die. All of these things are more a part of me, more essential to my every breath, that is, my so-called body. And what is my real body? I would like to acknowledge here that the oceans are a part of our body. When the oceans are healthy, we too are healthy. When the oceans are sick, we too get sick. Oceans too have to be kept healthy, otherwise we won't survive. Thank you.
Thank you so much. That was really powerful, and also bringing to mind the people who are impacted and affected by climate change, and the deep connection that many have. I'm now going to hand over to our next speaker, Abu Hussein, who's a Gambian fisherman and activist, who is going to also provide his views.
Hello, everybody. I greet you all. My name is Abu. I am a fisherman from the Gambia, but now currently living in Spain as an asylum seeker. I am very, very much happy to be part of this program, and also I'm happy to share my ideas about the decreasing of fish in the Gambia. First of all, it all started at the year of 2017 when our new government signed an agreement, like a bilateral relationship with China, to start fishing in our territorial coast and also build fish meal factories. So since the Chinese came and started fishing in our coast, we've been facing so much difficulties and so much decrease of fish because there is no relax in our sea and there is no control. And so I was against it because they have these illegal nets that are not supposed to be used, and they used to fish in places that are very much illegal to fish. They will be there fishing, catching fish, and also they introduce very bad nets to our local fishermen to be fishing. And our local fishermen, they were not having any choice because they also have families to feed. So going for fishing, spending money to buy fuel and food, spending hours in the sea, coming back without any catch, without nothing to give to your family to feed, is something very difficult. So this is what we are facing. So what I'm appealing is for help to at least have a control of the fishing and the type of nets that are being used in the ocean, because to be honest, fish is decreasing very much. In the Gambia, there is almost nothing, and fishermen are suffering as well as the locals that used to consume this fish, because the Chinese fish meal factories will take this fish for animal products, like for protein and other stuff, for their livestock and for fertilizers, whilst we, the locals, the Gambian locals, need it to feed. The fish will be exported to their country, and not the Gambian local will benefit from it. So I'm appealing to everybody. If there is a solution to this, we really need help. Thank you all.
Thank you, Abu, and thank you for your plea that you have also put forward, I think, to some of the panelists here. And I think we're going to hear a little bit more on this a little bit later soon. going forward, and some of the concepts and guidelines that are there to assist with this. Without further ado, I'm keeping a close eye on the time, and I see it's marching on, and I would like to give others also an opportunity to intervene, is to invite Dr. Edem Mahu, who's also virtually with us, and going to speak a little bit more about some of the other aspects that we need to take into account, for example, ocean plastics, and how this also impacts cumulatively with climate change. Over to you, Edem.
Hello, good morning. Can you see my screen?
We can see you, we can't see your presentation yet.
Okay, all right. Share screen. Are you able to see my screen now, please?
Not yet. I will let you know when we do.
All right.
We still can't see your screen.
I don't know why it's not showing. I have no idea, but I did share my slides with Senia, so if it can be projected from your end.
All right.
That would be
Just see if we can do it. Yeah, hold on a second.
Talk, but the slides, please. Not sure why.
Okay. Unfortunately, we don't seem to have received your slides in time, or haven't got them yet. So if you're able to speak without your slides, please do go ahead. I do apologize.
Okay, all right. So I'll just speak without sharing my slides.
Yes, thank you so much.
Okay, thank you very much for the opportunity giving me to talk about other aspects of ocean health, specifically on ocean plastics, exploring its connection to health and climate change. Plastic pollution of the ocean is undoubtedly one of the biggest challenges of our century, of the 21st century. From a macro size to a nano size, plastics have been detected in all ocean basins, including areas that are remote to human influence. To put things in a better perspective, about 30 million tons of plastic leak into the ocean every year, and close to 100,000 marine animals are killed by plastics from various means, either through ingestion or entanglement in the ocean. Now, to produce plastic, we have to use about 17 million barrels of crude oil every year. So clearly, it's not just a health problem, but also there is a link to climate change, which is also linked to your health as well. What is the connection with plastics and human health? Currently, 3.2 billion people, comprising 40% of the world's population, depend on fish for almost 20% of their animal protein intake. Yet, the consumption of seafood has been identified as the major exposure routes for plastics into humans when we take away inhalation from the air. Consumption of seafood is a second major exposure route for plastics to get into humans. Plastics have been found in various parts of the human body, including recently in placenta. It's been found in human blood. It's been found in the lungs and humans too. So it means that the plastics that we are introducing into the ocean are not only affecting the animals and the health of the oceans, but also are getting into humans. The additives that are used in plastics, such as the flame retardants, the perfluorinated chemicals, phthalates, bisphenols, and other associated contaminants, are known endocrine disruptors. So when these plastics are getting into human body, we need to be worried, because these endocrine disruptors are linked to various diseases that are really common these days, including diabetes, cardiovascular diseases, childhood and adulthood cancers, as well as reproductive disorders. Studies to clearly link plastics to human health are currently ongoing, but we know that some polymer types in plastics, such as the polystyrene, does have effect on the viability of certain human body cells. And so this has the potential to affect human health. When we talk about plastics and climate change, yes, the production and consumption of plastic and the management of its waste has great implications for our climate as well. New studies have shown that plastics are responsible for close to 4% of the world's total greenhouse gas emission. That is twice as much carbon emissions than the aviation industry produces, making it therefore a major contributor to global warming. The life cycle of emission of fossil fuel based on plastics can be looked at right from the extraction phase. So during the extraction phase, 61% of the 4% emissions that are coming from plastics are produced or emitted into the environment during the production phase. Then during the manufacturing, when we try to convert these plastics into other products, usable products, we release close to 30% of that 4%. Then the remaining 9% comes as a result of the management process itself, which is mainly through incineration and landfilling. Currently, it's less than 10% of the plastics that are produced are being recycled. And so most of these plastics end up at the landfill sites, and in some areas, they are just incinerated. So once we do this, we manage them in this way, we end up releasing these plastics back, or this carbon dioxide and other greenhouse gases in plastics back into the atmosphere, leading to climate change, which in itself has effect on the health of the ocean through ocean acidification, through warming, which is affecting marine organisms and what have you. Thank you very much for the opportunity.
Oh, thank you so much, and I'm sorry we didn't get your slides, but I think you've provided some really important information that often we don't hear about, and that's the actual impact of plastics and microplastics on human health, and getting that research out there is really important. I'd like to invite Dr. Karina von Schuckmann, who will also now just be giving us and talking to us a little bit more about the 2030 Sustainable Development Goals and the role of ocean science. Karina, over to you.
Thank you very much. Can you see my slides?
Yes, we can.
Okay. Thank you very much. So thank you very much for the organization of this very interesting and diverse panel. And I would like to bring a general point in terms of linking ocean science, data and services in support of achieving the 2030 Sustainable Development Goals. So I first wanted to leverage again, which has been done today during these different presentations from different angles, on the critical role, the central role of the ocean in the Earth system, and also for the achievement of the sustainable development goals. Particularly, the ocean plays a central role in Earth's climate, in particular because of its characteristics like this capacity of taking up large amounts of heat, large amount of carbon, helping to mitigate effects of climate change, but also with a huge amount of characteristics to transport these substances like heat, carbon, and other substances over large distances around the world, and also in the deeper layers of the ocean again, in order to support of mitigating the impacts from climate change. So the ocean is also represented here at the center of sustainable development. For the 3 pillars of sustainable development, the environment, society, and economy, with the major message that the ocean offers opportunities to face causes and consequences of climate change globally and locally, and calling for a dramatic scaling up of efforts towards ambitious mitigation and adaptation. This is again represented here in a different manner in terms of its central role for sustainable development, with putting the SDG dedicated to the ocean, SDG 14, at the center of the entire SDG Sustainable Development Goal framework. So again, the ocean offers opportunities to face causes and consequences of climate change at different scales. And the recommendation which had been formulated in collaboration with a interdisciplinary team in this publication is that there's a holistic approach that embraces sustainable ocean stewardship, informed by science, data, and services to support society and the economy, is required to create the future we want, which is the last part, the leitmotif of the UN Ocean Decade for Sustainable Development. This is a representation of the so-called added value chain, again of pulling up between the environmental pillar, societal pillar, and the economic pillar for sustainable development. And this added value chain is the core of ocean climate services that connects raw products and oceanographic service knowledge to high-quality data products and indicators, which can then be used in order to communicate across the different interfaces and between the different pillars of sustainable development. So these added value products can provide the evidence basis for agencies and reporting bodies, decision makers, other stakeholders, and the public, meaning societal and economic benefit. So we have the opportunity to take action to protect the ocean and improve the delivery of ocean information with end-to-end products developed specifically to inform ocean stewardship, policy, and ocean governance. Thank you very much.
Thank you so much, Green. That was really succinct and showing those connections really clearly. I'm going to now invite in-person speaker, yay, someone who could join me here on the stage, so I'm not sitting here all by myself, is Mr. Rubari, who's from the FAO, and I think we'll be able to also respond a little bit to some of Abu's comments that came across. Over to you, Taro.
Thank you. Hello everyone, I don't know if you can hear me, but Abu is left now.
Okay, maybe you can stay a few minutes. I think some elements of response will be of interest to you.
Yeah, because there are also some things that I really have in mind that to share.
So I believe you can just maybe hold on and we can just give some space to Tara to just have a conversation, and if you could just hear what she has to say, it might be interesting for you. Thank you. Just hold on a second. Thank you.
Okay.
Yeah, so thanks for the floor. So I had a beautiful speech prepared, but I think I have to react to some of the things that I have heard from the previous speakers. Probably because also it makes it more lively for the public who's sitting here, and thanks for staying for until the end. So I'm Taru Bahri from the Fisheries and Aquaculture Division of FAO. And I was invited here to speak about FAO promoting One Health approach as part of agri-food system transformation. But I think that I have to react to two things, and then I'll provide the elements that I had prepared about the fish meal, because this is really a critical question, because fish is critically important for human health and for nutrition, because it includes a lot of nutrients such as zinc, vitamin A, vitamin B12, omega-3 and so on, and it is recognized that it is important for human growth and for the human health, basically. And what is happening, as the fisherman from Gambia was saying, is that in many parts of West Africa, this fish is now transformed into fish meal, which is like a flour that is used basically to feed other animals, which is a nonsense. So together with the world fish, we have undertaken a study to assess the impact of this of the fish meat industry in West Africa. So both in marine fisheries and inland fisheries, so lakes and rivers and so on. And this study is going to be presented. And I was saying this study is going to be presented early December at the Fisheries Commission that covers West Africa, and with the purpose of alerting or raising awareness of the scientific commission that informs that Fisheries Commission, and get some policy advice on how to tackle this. And I think there's some signs of hope, because we hear a lot of negative messages and alarming situations. But there are some countries that have already started reacting on this question and have developed some management plans for what we call the small pelagic fish. So these are the fish that are used to produce this fish meal. And are starting to forbid the use of the small pelagic fish to produce the fish meal. So I think that it's a process, because what he raised also is the question of the illegal fishing. And there again, there are some international instruments. And for example, in FAO, there is the only legally binding instrument, meaning that once the countries have ratified it and signed it, it is an obligation from international law to apply it, which is the Post-State Measures Agreement, which is one of the instruments to fight against illegal fishing that forbids basically a country to land its catch when it is illegally caught. So of course, there's still a lot of work that needs to be done, but I think that the instruments are being developed and that we're making progress. So I don't know if I have exhausted my speaking time, or if you want me to. Okay. Then on the plastic, there's something also that I wanted to say on the plastic. So the plastic is an important question, of course. So, but it has to be put in a global perspective of plastic use and plastic production, because it is true that it has been widely said that seafood is the first source of microplastic intake for humans. But this data are currently questioned, because we have found plastic in beer, in salt, in air that we are breathing, and beyond the microplastics. Now the big challenge are the nanoplastics, and this is extremely difficult to study because when you enter in a laboratory to study nanoplastics, you have already contaminated, the laboratory. So it's extremely difficult to understand. And nanoplastics are everywhere, as in on this table, and on the paints that have been used for this pavilion. So it is a critical question. And I would invite you to consult the FAO report on microplastics in fisheries and aquaculture. where there is a risk assessment that has been done with the data that were available at that time in 2017. And that basically conclude that given the amount and using the extremely high amount of microplastic, the highest amount possible of microplastic in fish, it concludes that it is more dangerous for your health not to eat fish than eat fish with microplastics. Also, because there's an important element that we need to be aware of, is that when fish ingest microplastic, it gets in their guts, right? And usually we don't eat the guts of fish. You know, we eviscerate the fish before consuming it. So except for crustaceans like shrimp, or when you eat small fish, small fried fish, you eat it whole. So this is where you ingest microplastic. Or when you eat oysters or mussels, this is when you actually ingest microplastics. Anyway, so I just wanted to give some nuance to this narrative, because it's extremely complex, without minimizing the importance of acting on this question. And then another thing I wanted to say about this is that there is this whole I think global action on plastic removal from oceans, and when it comes to fisheries and aquaculture, there is FAO is engaged in a global study on assessing the sea-based sources of plastic, because fisheries and aquaculture have been accused of being the main source of plastics at sea, and we're looking into that. Knowing that there are also technical guidelines on the abandoned and lost fishing gears, which are recognized to be an important source of plastic pollution in the ocean. Then I think that to maybe close, I would just go back to what I had prepared, because there are some elements that I would like to highlight in there. So when it comes to food safety and biosecurity, they are recognized as important sustainability challenges in fisheries and aquaculture. So I'm happy to point you to the work that my colleagues are doing, for example, on harmful algal blooms that are expected to be, to increase in the context of climate change, because we're in COP, so we talk about climate change, and also on antimicrobial resistance. But I think this has been mentioned by another speaker. Then something that I wanted to say, going back to nutrition and human health, is that fish is a vital source of essential nutrients, as I was saying earlier, and it is good to note that the human consumption of fish has been increasing steadily between over the last decades. So going from 10 kilos per person and per year in the 60s up to 20 kilos, we're around 20 kilos now. But it has actually a wide range of variability, because in some areas of the world, the consumption eventually is zero, whereas in other areas it's 100 kilos per person. For example, in some islands in the Pacific. Half of the countries that have public health policies identify fish consumption as a priority, which is, which could be improved given the importance of fish for human health. But of course, we all know and we all hear that fisheries resources are under a lot of pressure. That 1/3 of fisheries resources in the world are overexploited. But there's a very interesting figure, is that when you fish and process the fish, you actually discard 30 to 70% of it. Whereas, for example, the bones and the skin these are the most nutritious part of the fish. It's not the flesh, it's all the things that you throw away, which is quite interesting, isn't it? And we have done some experiments with the colleagues who deal with nutrition to develop some some nutrition and low cost food products that you could use in school feeding programs or for young children or pregnant women or these kind of things. So there again, it's also a matter of how we use our resources, especially in this context of climate change, where fisheries resources are going to be under increasing pressure. So we really need to use them better. And then I think that part of this mission impossible of talking in 3 minutes about health, climate change, fisheries, and nutrition and biodiversity, I just wanted to flag that the aquatic food sector exploits almost 3,000 species in capture fisheries and farm over 650 species. This is quite unique in food systems. I don't think there's any food system that reaches this level of biodiversity. But of course, there's a growing pressure on this biodiversity in aquatic systems, and if nothing is done, I think there's a UNESCO estimate that suggests that if nothing is done by 2100, we will have a loss of 50% of this biodiversity. So I think it's really important that we do something about it. And then just to close, because I think I went way over time, I'll just point you to this QR cards that I brought here on blue transformation, which is the new approach that FAO is advocating on improving fisheries management, developing sustainable aquaculture, and improving the efficiency of value chains to minimize waste and use the fish better. Thanks for your attention.
Thank you, Tara, and it's also good to see it within a systems approach and how it all fits and feeds together. Last but not least, we have our final speaker, and I'm really trying, but we're running out of time, that we will have some questions, but I'm sorry, I don't think we will. But Catalina Pizarro will be presenting and talking a little bit about the Global Treaty on Plastic Pollution. So we're back to plastic again. Over to you, Catalina.
Thank you. Can you confirm that you can hear me?
We can hear you.
Okay, thank you. Well, as the previous speakers have mentioned, the science for example, plastic pollution is lethal for many species, but it can also alter the overall carbon cycling. And throughout its life cycle, plastic also contributes to climate change. Currently, there is no global binding agreement with specific and measurable targets to address plastic pollution. However, there are at least 10 multilateral environmental agreements and 15 regional instruments relevant to marine pollution and hazardous waste. The current system, however, has some gaps. The approach remains fragmented, and there is no single legal instrument that specifically has as its primary goal the elimination of marine plastic litter and microplastics. An international legal instrument with a governance structure and clear mandate could provide opportunities for a cohesive and targeted approach to reducing and eliminating the negative impact of marine plastic waste. And in response to growing concerns on the impacts of plastic pollution on human health and environment, over the years, the United Nations Environment Assembly, best known as UNEA, has passed a number of resolutions on how to address plastic pollution, always with a focus on the marine environment. However, UNEA Resolution 5/14 has been called the most important international multilateral environmental deal since the Paris Agreement. The resolution is entitled End Plastic Pollution Towards an International Legally Binding Instrument and calls for the development of a legally binding instrument on plastic pollution, including in the marine environment. Addressing the full life cycle of plastic, the resolution requested the Executive Director of UNEP to convene an Intergovernmental Negotiating Committee, or INC, to commence its work during the second half of this year, with the ambition of finishing its work by the end of 2024. Substantive aspects of the negotiation are defined in the resolution in paragraphs 3 and 4. The treaty could include both binding and voluntary approaches, which nevertheless does not interfere with the nature of the instrument, which will be a treaty and therefore binding on parties. The instrument should be based on a comprehensive approach that addresses the full life cycle of plastic, taking into account, among other things, the principles of the Rio Declaration, as well as national circumstances and capabilities, including provisions to promote sustainable production and consumption of plastics, circular economy approaches, to promote national and international cooperative measures to reduce plastic pollution in the marine environment, including, importantly, existing pollution, national reporting, periodical assessment of progress, and scientific and socioeconomic assessments related to plastic pollution, compliance, among other relevant provisions. Thank you. Making it very short this time.
Thank you. Yes, I think it's very difficult to put a whole treaty into a few little sentences in 3 minutes. Unfortunately, we are run out of time. It's 12:45 now when the session's supposed to end. I would really have loved to have heard some more from our online speakers, but thank you very much for your presentations and for your time. And also thank you very much to the viewers who have listened to us. I'm really sorry that we can't give anyone some more time, but I think just some central parting words is ocean is central to our health. And as we sit here in the lungs in the Health Pavilion, within this beautiful structure that's within here, is realizing that every breath we breathe also is contributed to our oceans, and they say at least 50% of the oxygen is produced by the oceans. We also know the ocean is actually impacted quite negatively, which is going to have an impact on our food systems. And we've also heard how the SDGs and the role of the ocean in achieving the SDGs is really important, including health and well-being, as well as for poverty alleviation through the many of the food systems that are in place. So, and we've also learned how the ocean could have some of those particular solutions through biodiscovery and some of the microbes that can provide us with what we need for to help us with some of the health issues. So again, thank you so much for your time. Thank you to Land Body Ecologies for partnering with us on this event. I'm sorry we don't have time to give everyone a space to introduce themselves. Have a very good rest of COP27. Thank you.
Wow.
Thank you.